Okay, so this should be what we're working on. I feel like these they're just kind of reviewing, like, if you understand the structure of the Cartesian coordinates. That's reviewing if you know what a solution is, whether you can determine whether a point's on a line. And these are, I believe they just say graph these things, graph by plotting points. So I feel like the first 5 of them, and let me pull up maybe sheets 3, 1. Does everyone want to go on here? I feel like there's still some people like doing kind of the wrong thing on the homework. Do screen 2. So just to be clear, like, the book problems that you should be doing are the ones that are on the top of this worksheet. So they may or may not match up with the things that say book problems. For this lesson, I think they're all on that other thing. But I think we can do the first 5, 3, 7, 11, 13, 17. I think that will get through the first 3 sections that I was talking about. And what do we got more? 4, 5. Yeah, these will go. I feel like this lesson should go pretty quick, hopefully. Any questions about anything before we hit the breakout rooms?
I have a question.
Oh yeah.
On the book work, I was looking over it, just to kind of peep it. For number 3 and that's E, when it say 1 comma 14/5. When I see that fraction, I got like a little hesitant, like, I don't know that word, Okay. So we'll talk about that later, or?
Yeah, well, we're gonna go to groups now to do those problems, and we'll come back and talk about them.
Okay, gotcha.
Recording. Okay. Whew. Do you want to stare at a fly on the ceiling? Develop some new coordinate systems or something? I don't know. Who knows? Questions about this one before we move on? Okay. Oh no. All right, what was the next? 7?
Yes.
Is it a solution to the equation? And then is the point on the line? So there are 2 questions. I think I'll start with probably answering them both. If we look at this equation, it's 0 minus 3. Let me get that graph on there a little better. How do we know whether that's a solution to the equation or not?
Like, we pick up x equals 0, and then we did the equation to find y, and
X is 0 and y is going to be what?
to be minus 3.
Yeah, okay. So we're going to do x is 0, y is a minus 3. That's what our ordered pair here tells us. This is x. This is my y here. Mm-hmm. And so I think you said it. We want to plug that thing in to our equation. And we plug it into our equation to see if it's what?
If it's true, the true statement.
If it's true. We're looking for that truth in there. Yeah. Is this a true statement?
Yeah, and is the solution is directly in the line, right? This 0 minus 3 is in the line and is the solution for the equation.
So we're getting minus 3 as a minus 3. If we do a half of 0, it's going to be 0.
Yeah.
0 times anything is 0. And then we subtract 3, it's going to be a negative 3.
right?
So is it a solution?
Yes.
Yes.
My S's look horrible on here. Okay. It's like trying to draw curves on an Etch a Sketch or something, man. Is that a point on the line?
Yes.
Yes, it's in the line.
Right there.
Yeah.
0 minus 3 is a point on that line. Okay. Someone have a question? I hear static or something. I don't see who's talking. Try to make my window a little bigger. Okay. Questions about this one? I'm going to have to clear this off in just a second. So it is a solution. It is a point on the line. The next one. How do I do this one?
It's the same thing.
It's the same thing. Okay. So I believe this is my X. This is my Y. So if I plug this in, what is this? Minus 2 is equal to a half of what? 2 minus 3?
-3, and then we are going to have 1 -3, and the result is -2.
And so a half of 2 is really just 1.
Mhm.
And if we look at this, minus 2 is equal to 1 minus 3 is also a,
-2.
so this checks. So is it a solution?
Yes.
Absolutely. That is what that means. That is part A. It is a solution.
Yeah.
The next question is that a point on the line?
Yes.
Yeah.
What do you notice? Is there any sort of maybe inference we can draw about points on a line in a solution?
Because when we draw them, the 2 points are in the line for the 0 -3 and the 2 -2.
So this was a point on the line. We plugged it in, and guess what? It is a solution. This was also a point on the line. We plug it in, guess what? It's a solution.
Yes.
So when we look at this equation and we ask what are solutions to this equation, we know that this thing graphs out to line. The solution should look like every point on that line. That's what we're saying. It's saying the same thing, right? Part A and part B are really asking you the same question. Part A is just asking you to, hey, solve this symbolically, right? Part B is like, look at the line and solve it graphically.
Teacher, excuse me, in this case, we can just say like 0 -3 is the solution and is in the line, or I need to specify my answer.
So for part A, you should probably do this work, this symbolic work, right? You should do like the -2 equals a half times 2 minus 3 and show me that it is equal. Show me that that is a solution symbolically. So part A I should see some work for part A. Part B, you're probably just going to look at the graph and circle it and say yes or no. I don't know how to really show work for that. You're going to have to look at the graph.
And to say directly yes is a solution and is in the line, I think.
Yeah, so it is a solution. It is on the line.
Okay.
And those things should match up because it's the same question. Just we're solving it differently, right?
Yeah.
All right, so let's go through the rest. Same thing. We're going to do it twice. So we're doing the same thing over. So if you're lost, try to get like one step ahead. See if you know how to do it. All right, so what should this equation look like?
It's the same thing. We replace x with -2 and to find the y.
Okay. Who else? Can I get someone from room 2? Y'all are being quiet. Everyone's quiet. I need more other people speaking up.
For that one, I had got -4 equals I have times -2 minus 3.
1/2 times the -2 minus 3. Is that what you said?
Yes, sir.
Okay.
And then,
Negative.
I got -4 equals -1, -3. And I brought it down, is -4 equals -4.
Yep. I should probably start with question marks over these. We don't know whether they're equal. We're trying to check whether they're equal. And if you look, this should also be a point on the line, I believe, right? -2, -4 is right there.
Yes, it's on the line.
It is a solution. It is a point on the line. Last one. This should look like, this is my X, this is my Y. I will go ahead and jump into this a little bit, maybe. It should look like 1 equals 1/2. The X is 4, and we're subtracting 3. Does this one work?
-1, but it's not on the line. So would that still be considered a solution? Because it's not on the.
Okay,
not
so we're
on the
getting,
line, so
we get 1 on the left. What are we getting on the right?
-1,
-1.
Is that true?
not a solution.
No, that is not true, right?
Mhm.
One is not a -1. If I'm getting paid $1 and I'm paying $1, those are two different things. But it's coming or going, right? So it's not a solution. That's
Excuse
not-
me, teacher.
This is D.
You are in part C, right?
Part D,
It's
the last one.
It's not C, it's D.
70, 4,1.
Oh, okay. Maybe
Um,
it's-
And this is not solution. I can't write on here. Okay.
So number, okay, I'm not understanding because number B is a 2, -2, but because it is on the line, it is considered a solution. Well, I don't understand how come I don't really understand that. Because it's on the line itself, it is considered
Okay.
a solution.
The solution and whether it's a solution or not is coming from solving it symbolically. And so when we solve this thing symbolically, we get a true statement. For this one, we get a true statement. For this one, we get a false statement. We get something like 1 equals a -1. That is not true.
But number B is 2, -2,
And when we plug it in, we get a true statement.
because it's on the line.
Yes, so those two things correlate, right? Because it's on the line,
Right.
it should solve out symbolically. But what they're asking in part A is they're asking for you to solve it symbolically, to show that it's a solution symbolically. Because using your line as proof that it's a solution is not a good method, because you can draw that line off really easily. You can look on that line and you can see what point is on that line. Graphical representations are not good ways to prove things because they have those faults in them, right?
Right.
They're not good. Yeah. If we're going to prove a property, we really need to do it symbolically. And so we want to prove this property that this thing is a solution. They want the symbolic work to show that it's a solution. If we want to show that it's a point on the line, we can kind of just look on the line that they provide us and try to see that it's a point on there. It's not as good or solid a method as maybe like symbolic said.
I don't understand. Because I understand that. The only way that I was able to figure out that number D was not a solution was because it was not on that line, but the other ones were on the line. On the coordinated line that is graphed right here. So if it's I don't really, I went and I did the solution itself. I put everything that I was supposed to, the X and the Y in there, and then I solved the equation. But I'm still not seeing how one could be a solution and the other one not if I don't see it on that line.
So you're asking how to see whether it's a solution or not symbolically. So when we plug this thing in, when I plug in part B, right? This is the work for
Right.
B. Is -2 equals -2, is that a true or false statement?
It's true.
You mean 2, -2?
True.
Mm-hmm. Right, this is saying -2 is equal to a -2. Is that true?
Not, no. I mean, yes, I guess so. But
Yeah,
I'm
like
I
a number
guess
is
so.
equal to itself, right? Like it's the same thing. So if we have a number is equal to itself, that's going to give you a true statement. If we have something like this, one is not equal to, one is equal to -1, is that true?
No.
So this is not a true statement. And so that is why it's not a solution.
Oh, okay, I get it now. It has to equal what the
Mhm. It has to give you a true
Inside-
statement.
so the true statement is 2 equals 2, but
Mhm.
1 and -1 is not a solution because they don't equal. They're not both the same size.
Yep.
Oh, okay, I got it. I was like, I don't get it. Okay. Cool.
All right. So that is that one. What was the next one? Graphing stuff.
The only one feature in this exercise is the D for like 4 and 1 is the not the true statement. It's like it's not a solution here. I mean,
Yeah.
Yeah. Okay. Thank you.
Okay. And this one. What are we doing? 9, 11? What was his numbers?
I think 13,
11, 13, and
11.
11. Oh, okay.
11, 13, and 17 were the ones we're doing.
16.
All right. So 11 says y equals 3x minus 1. How do I graph this thing? How did y'all graph it?
Plotting X and Y.
Okay. So what did you do? Just like a T chart?
Yeah.
Oh, okay.
I did a T chart, but I did so I did the lowest ones that I could do. Is that okay to do? Like I did 0 for the X, I did 0 and 1 and 2 to find a solution on the
Playing
chart.
from desktop UAC.
So do you, is there a specific number that we are supposed to actually do? Like it's 3x, y equals 3x minus 1.
With these linear equations, I think you're pretty good doing just like 0, 1, and 2 probably. Would probably get you there.
Okay.
Because
mine plotted to in 1 and 3.
if we plug in 0 to 11,
Or
what is
2.
that going to give us?
I had
0,
got
-1.
0, -1.
And then 1.
1x equals 1 equals 2, y equals
3. What is that?
X and 2. X is 1 and 2, right?
1 and 2. Yeah, that's it. So we're doing the same thing. We're plugging in y equals 3x minus 1 into this thing. I don't have enough room to write right here.
Yeah. So it's just like doing the X and Y, right? So you basically you create you make a line with X on one side and Y on the other side, and usually the normalcy of this equation is to start with the X coordinates first and starting, I mean, like for me, like I said, I do the lowest ones that I could do, but you can, I think maybe.
So these are good points, and we know how to plot points. So I think this will probably get us our graph pretty well. Another thing people like to do is they like to get their intercepts. So you can graph it also by just getting your intercepts. If we do this, this one, well, let me grab my pen again. This one gave me my y-intercept. If I want to get my x-intercept, what do I plug into where?
x equals 0.
Ooh, careful. Which one is 0?
It's 0
Why?
is 1.
Y is my 0. So if we look at this, if we look at this equation with my Y being 0, how does that change things? It's not quite as straightforward in solving then, right? I have to do a little bit of back solving, I think.
Yeah.
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 I think I'm gonna get what 3x is a positive one. I don't know, I'm gonna swap things around a little bit here, maybe. I'm adding 1 to both sides. And then what, dividing by 3. So this might be another point people get, but they may not like that too much because it is a fraction.
Mm.
It's not too easy to plot, but it gives us a good idea of where it should be intercepting the y-axis. Trying to think of which one I'm on. Sorry. And now we want to plot this thing. So we plug in numbers to solve for these points. We plug in numbers to our equation. We have either a t-chart, or you could do it in slope-intercept form too. Have we done that yet? Or do they just do things with t-charts in this section? I think they might just do t-charts in this section.
Yeah, they just do t-charts.
Yeah, if you know slope-intercept and you did it slope-intercept form, you know your intercept is that number and you know how to do the slope. That's fine. That's coming up in like two or 3 days, I think.
Yeah.
It's
Tomorrow.
coming
So-
up pretty quick.
So for these questions, do we graph them?
Yeah, so now we need to graph these things, 0, -1. I'm not going up or down, but I'm not going left or right, but I'm going down 1. Sorry. I'll say it right eventually. I think it needs to go like right here. Maybe if I do a little X in the spot, it's a little better. 1, 2. I go right 1 and up 2.
Two.
So like right in there.
5.
2, 5 is 1, 2, 1, 2, 3, 4. Try to count it as best as I can on here. And those are my 3 points.
Downwards.
I'm not going to try to graph that fraction. I'm just going to like try to do this as straight as possible. That's not too bad. I thought it was going to be worse than this bad. And the other point was like what, 1/3 0? Does it look like it goes through there? Pretty close. Right in here. That looks about like 1/3 0, right? Questions about this guy?
Yes, please.
I did want to ask for future reference if we could use a little bit darker colors. I'm having a little bit of hard time seeing it.
Okay. Is that better?
Yes, thank you.
Okay. I can go black as well.
Excuse teacher,
But-
excuse me, teacher. In this case, we can just upload 2 points, like what we have 0, -1, and 1, 2, or we can upload.
So the minimum requirement to draw a line is
Uh-huh.
2 points.
2.
You have to have at least 2 points to define a line.
Okay,
To
because
draw a good line, you should really be getting at least 3 points if you want to draw it by hand. That's usually what I suggest.
because in this exercise for number 11, I did just 2 points, like 0, -1, and 1, 2.
You should probably get a 3rd point just to make sure you're drawing it straight if you're drawing it by hand.
Okay. Thank you.
But I know in the book they did it with just the 2 intercept points and they drew lines with just the 2 intercept points. So technically you do need only 2 points. The 3rd one's just for beauty, right? We're doing what, 11, 13, 17?
13.
I have a
Ooh,
question.
what happened?
11.
Yeah, what about?
When I made my t-chart, I know that you just said that we could use 0, 1, and 2, but I had did -1, 0, 1. Was that okay? Or
Yeah, you can use like almost any number you can think of. It's like any number you can plug in there.
okay, I was just kind of double checking because it was
Just certain numbers are really easy to figure out certain things for. It depends upon the problem. Usually 0 is a really good number to plug in because zeros disappear or they added nothing, right? And so things get really simple if we start throwing zeros in there. Got my X's, I got my Y's. I want to do 13, I believe.
Yes.
What'd you plug in? Group 3, Charmaine,
did.
Gaia, Kayla. Give me some numbers. What are y'all doing?
Can I do it?
Yeah, you're in group 3.
Ah, okay. In this case, we have y equals minus x minus 3.
Y
And
is
then,
what? Yeah, okay.
okay, and then I will give the number for x. When x equals minus 1, I will start with the negatives. When x equals minus 1, y equals minus 3. This one is my first point. The second, when x equals 0, y equals minus 3. The second point, I have 0 minus 3. And the last one, I did x equals 1. When x equals 1, y equals minus 4.
Ooh. Okay, so when X is a -1, what is Y equal to?
Minus 2.
Oh, there's a minus there. Oh, it's a double
Yeah.
negative.
Yeah.
Okay. Yeah, we gotta be careful with this one. Apparently I don't know how to breathe anymore. Okay, so Y equals minus X minus 3. So if we start and we plug in a -1, it's a minus minus 1 minus 3.
Yes.
We have to account for this negative that is in the equation.
And then it comes 1 minus 3, and it's minus 2.
Yeah, and same thing, if we plug in a +1, this is 1, Y equals a minus X. My X is +1, a minus X would be -1 minus 3. So this one definitely got to be careful with
Yes, it comes minus 1,
positive
minus
negatives.
3, minus 4.
And we get the slope. When we get to slopes, we can also use slopes to make sure we didn't mess these things up, to kind of double check ourselves.
Teacher, in this case, we can do like 3 points minus 1, 0, and 1 for the x's. Right?
I'm not sure I understood what you're asking, but you said something about the 3 points.
Yes.
So we have the 3 points. We should be able to graph it, right?
Yes.
So let's graph these 3 points. 1
Okay.
minus 2. Let me expand this. Okay, I want to do -1 minus 2. So I want to go left 1 and down 2.
Down 2.
So I believe I'm like right in here. I want to go 0 minus 3. So I'm not going left or right, but I'm going
In the axis of y negative.
down 3.
Yeah.
I'm going right 1 and down 4. So I go right 1, I go down 1, 2, 3, 4. Should be right in here. Ooh, what are the odds this is going to be a straight line? Let's try to do it.
It's straight line.
Try to draw it as straight as possible.
Yes.
You
Because all
should
the
really
points
put, the other thing when you draw a line, you should really put arrows on the end of your line.
the arrow.
Arrow, because that line keeps going.
Okay. Because me, I just put like the line again. Okay.
It should really have arrows to indicate that line keeps going and going.
Keeps going down.
Yeah, because I don't really like, I'll go over this. I don't really like when people just do like little lines. Like sometimes they'll just do something like that. It's like, that's not what we're doing. That's not the solution. The solution is like everything along this thing, right?
Okay.
I want the whole thing. I want it to go like the length of your graph as much as possible. Don't be doing these little rinky-dink things where I can't see. Because now I don't know, like, is this a solution over here, right? If I
Yes,
draw
it-
it all the way, now I know that's a solution, that's a solution. I can pick out other solutions on that line. If you draw a little short rinky-dink thing, you're doing yourself a disservice. I don't know. You don't
teacher,
know what your solutions are.
excuse me, teacher. In this case, it's going down, right?
Uh-huh.
Down and quarter of the 4 quadrant.
We just draw arrows on the end. Yep. And then the last one I think that we're doing. Yeah, on time. Okay. The last one we're doing is what, 17? Oh, I like
Yes.
this one. This is where picking your numbers a little smarter might come in, unless you really like working with fractions. If I see 17 says y equals a half x plus 2, what do you think are good things to pick? 0 is a good one. I'm going to do 0.
One half?
Oh, if you do a half, it's going to half a half.
Oh, yeah.
Do it the other way. I think you're thinking the right thing.
Negative one half?
Oh no, the other direction. Not
Okay.
negatives and positives. You're dividing. We want to multiply. Multiply by what? Multiples of 2. So if I pick multiples of 2, it will save me a little bit of headache when I start plugging things in and start having to half it. Having to half it. Okay, sorry. That's a tongue twister. What is this? 2? What else do you want to pick?
4, 6.
4. That's exactly what I would pick. 0, 2, 4. I would like personally pick, and someone asked about this, I would personally pick small numbers or numbers that work out really nice.
Mm.
If
In
you
this
don't-
case, let's keep at minus 1, 0, and 1, the small number.
So who is in, let me get group 4, Carson, Jade, Sage, or Vanessa to help me out with this. If I plug in 0, what am I getting?
For 17,
Yeah.
if you plug in 0, you get, oh, like total or just
Yeah, what do I get for my Y?
2?
Yeah, that's it. And if I plug in 2?
3?
Yeah. 1 plus 2, that gives me 3. If I plug in 4?
4?
All right, let me double check. 4, half it, that gives me 2 plus 2. Yes, that's it. 4, 4. Questions about how we got these points? Are we understanding how to get points from an equation? And then the next thing, let me get this a little larger. And we got to plot these points. I've been kind of lazy, but every time you do a graph, you should really put your X and Y axis on there. You should really label your X and Y axis. Do as I say, not as I do, right? X is what, 0, 2? Can we graph that thing? We're not going left or right. We're going 0, 2. 2, 3, we're going right. 1, 2, we're going up 1, 2, 3 right in there. 4, 4, we go right 4, and we go up 4 right in there. We have 3 points. Do you think you can draw a graph from those 3 points? Hopefully, we can get a graph. questions about this? Okay, so I think we got 3 more, 5 more. Is that what it is? I think I want to do the next. $17, $27, $33, $35. I think I want to do those 3 next and then come back and then we'll see where we are if we could do those last 2, I think. So we're at 27, 33, 35. Yeah, 45, and those last 3 are together. So we got 6 more. So let's do the next 3 and then we'll see how much time we got left and we might do those last 3. So let's go back to breakout rooms. Any questions before we head back out? Are we getting these problems that we just went over, hopefully? That's what I'm
Yes.
hoping.
Real quick, could you just show number 27 on your screen? Because I don't know if my printer missed a page.
Okay.
Mine
27.
also, yeah.
Oh, it's on the bottom here.
Because- Yeah, but there's no equation.
Okay, so A is x equals a
Yeah,
minus
mine's the
2.
same way.
A should be x equals a minus 2, and B should be y equals a minus 5. So these were those special cases that I talked about that you're going to go talk about in your group, and then we'll come back and talk about them again.
Okay.
Oh, Jesus.
So hopefully at least one of y'all paid attention. Right? That's the hopes. All right. Any more questions? We're going to head out to groups. All right. I have 0 on my x, I have 0 on my y. If x is 0, y is
0.
and if y is 0, x is
0.
0.
and if you try to graph this,
It's just 0, 0, right?
what is that? How do I draw a line from this?
And then we need to create another point to draw
You got to
the line.
create another point for this one. So I don't know. I'm going to do maybe 1.
This exercise it's 51, teacher, right?
If I plug in 1 to my x, what am I getting?
-2.
Yeah. So I'm going to have to do another point. What point? You can pick whatever point you want. Throw in another number, but I have to get 2 points. If I do my intercepts, the intercept here is the origin. And so my x-intercept is the same as my, my y-intercept. And so it only gives me 1 point. So I'm going to have to do another point. 1 and like a -2 is going to be, I don't know, in there. 1 and like a -2. To give you a line going down. I think those previous 2 gave us a line going up.
Yeah.
I think this one gives us a line going down. Okay. Are there any questions?
Yes, please. Is it the 51?
This was 57.
57. Okay, because it confused. Okay, okay. Thank you.
Mm.
So for 57, it would be one of the plots would be 0, 0, and one of them would be 1, -2.
Yep. And you can pick
Oh,
more.
okay.
Yep. You can pick pretty much any number to throw into the X, right? Just 1, 2, 3. Those are really pretty numbers and easy for me to plug in. I really like small numbers will get you there for these graphs at least. No need to overcomplicate things if you don't have to. Any questions? We are overtime by 5 minutes, I think.
-2.
But I am here for questions if y'all got them.
I have a question, kind of, sort of. Can you hear
Okay.
me? All
Yeah, I can hear you.
For 45, 51, and 57, when we had did it by ourselves, I had ended up doing I did something wrong on my paper, but when you went over 45 and I see when I did wrong, do you want me to erase what I did wrong or just keep it on my paper? But I fixed it on my paper. It's just a simple fact when I turn it in, I don't want to be like, hey, I did this, you know, but it was that, or it doesn't matter.
I mean, if you're doing it for your notes, it's okay if you keep like your work in there. But I would try to maybe box the correct work and like highlight that this is the correct work.
Okay, gotcha.
I think we're doing the bookwork completion pretty much anyway.
I'm still not understanding 57. Like so you plotted the X as the 0 and it came up 0, 0, right? But then because it doesn't have another coordinates, you can add any number.
So
I
it's
don't
just going back to the T chart like you were doing previously. So doing the intercepts, the intercept method only got us 1 point. And it got us 1 point because the intercepts are the same. It's the origin in this case.
Okay.
And so when you have the origin as your intercept, your x-intercept is going to be the same as your y-intercept. It's 0, 0. It's the same point. And so when we tried to solve for intercepts, we were expecting to get 2 points, but we only got 1 point because it was the origin. And so we have to extend our t-chart. We have to get another point to get 2 points.
So I can do, like, say for instance, I can do y equals -2 times 1.
Yeah, that's what we're doing.
And that would give me another coordinate of -2. Right? Is that
so
right?
this is where we got that point from, right? We plugged in 1 to the x, we got a -2 out of our y.
Okay.
We could plug in other numbers in there. If we plug in a -2, right? We just gotta get some other number. -2, 4, I believe is gonna be the point when I plug in -2. -2 times the -2 will give me +4.
Oh yeah. Yeah.
So we can
I
plug
see what
in,
you're saying.
you can pick
Anything
just
we
about
want.
any number you want, which is why I'm gonna pick number 1 and 0 and stuff that's really easy to solve for.
Yeah, that's
Yeah.
what I was trying to do, because sometimes they become big numbers. They become bigger numbers if you don't choose the right numbers.
Yeah.
And then you be trying to figure out, how am I gonna plot this? Yeah. Okay, got you.
All right.
All right. Is that our time?
Yeah, we're past time. I'm just here for questions at this point. If y'all gotta go, wherever y'all going.
Okay, thanks everybody and have a good day.
All right.
Thank you.
Y'all take care.
Thank you.